SpaceX is risking everything on Starship Flight 12. They're pushing a brand new, untested Block 3 vehicle through a brutal and unprecedented testing schedule, faster than we've ever seen. We're going to break down the radical new design of Block 3, the critical tests happening at Starbase right now, and the one major change to the launch pad that could decide the fate of the entire mission. This aggressive campaign could either blast us into the future or end in a truly spectacular explosion. What's happening at Starbase right now is not business as usual. This isn't just another small step forward for the Starship program. It's a calculated, high-stakes leap of faith. The entire strategy has shifted. For the past year, we watched the Block 2 vehicles fly, fail, learn, and finally succeed, closing out a chapter of the program. That era is over. With Flight 12, SpaceX is jumping to a completely new generation of hardware. Don't think of it like going from an iPhone 14 to an iPhone 15. Think of it like ditching a flip phone for the very first smartphone. It's a foundational change in design, capability, and how these rockets are even built. And with any great leap comes great risk. The vehicle slated to fly, Booster 19 and Ship 39, carries all the hopes and pressures of the entire program. They're the first of their kind, built on lessons learned from a catastrophic failure, and they're being shoved through a testing gauntlet that crams months of work into just a few weeks. The question hanging over Boca Chica isn't just when Starship will fly again, but will this audacious gamble on a brand new design actually pay off on the very first try? So what exactly is Block 3, and why is it such a monumental risk? To get that, we have to talk about its predecessor, Booster 18. Back in November of 2025, Booster 18, the first Block 3 Super Heavy ever built, was moved to the Massey's test site for what should have been routine qualification tests. It never even made it to a cryo-proof. During a simple pressure test using gas at room temperature, the booster's liquid oxygen tank ruptured, and it did so violently. High-speed cameras caught a massive sheet of stainless steel peeling away from the booster's side as the tank depressurized in a split second. The failure was a brutal but invaluable lesson. It happened not with super-chilled propellants, but with simple gaseous nitrogen where the steel alloy is actually weaker. It proved that the new Block 3 design, with its taller propellant tanks and thinner steel barrels meant to save weight, had pushed the structural margins to their absolute limit. The loss set the program back, but it also gave them a critical data point that has shaped the entire strategy for Flight 12. SpaceX wasn't just building a replacement, they were building a smarter, stronger version based on that failure, and they knew they had to test it with extreme prejudice. Enter Booster 19. This isn't just a patch job. Block 3 is a different beast. A shift from one-off prototypes to a vehicle designed for mass production and much higher performance. The changes are everywhere. First, the power. Flight 12 will be the first time a full stack flies with 33 next-generation Raptor 3 engines. We'll talk more about these incredible machines later, but just know they are a serious upgrade, promising between 19 and 22% more thrust than the Raptor 2s used on every flight before this. That's a massive power-up which demands a vehicle structure tough enough to handle it. Then there are the aerodynamic and structural changes. One of the most obvious differences is the grid fins. Block 2 boosters had 4 of them to steer their descent. Block 3 cuts that down to just 3. It's a move that optimizes control while shedding a ton of mass and manufacturing complexity. Less is more, but only if your control is absolutely perfect. Internally, the whole architecture has been rethought. The interstage, that ring connecting the booster and the ship for hot staging, isn't a separate, jettisoned part anymore. On Block 3, it's built right into the booster's methane tank structure. This simplifies things and removes a failure point, but it also means the top of the booster has to withstand the full fury of the ship's Raptor engines firing just meters away. Even the ship's dimensions are different. The Block 3 ship is about 1.5 meters taller than the old Block 2 design, allowing it to carry more propellant, an extra 100 tons in fact. Each of these changes, more powerful engines, a new fin layout, an integrated hot stage ring, thinner tank walls, is a major engineering leap on its own. For Flight 12, SpaceX is rolling them all into a single, unflown vehicle. The chance for some unforeseen, disastrous interaction between all these new systems is huge. This isn't an iterative step. It's a generational leap. And that's why the testing for Booster 19 has been so ferocious. SpaceX isn't just checking boxes. They're trying to find the breaking point on the ground before it finds them in the sky. The memory of Booster 18's failure was looming over Starbase as Booster 19 rolled to the Massey's test site on February 1st. The pressure was on, and SpaceX responded with a testing campaign so aggressive it felt like a throwback to the early, wild days of Starship prototypes. This wasn't going to be a simple pass-fail. This was a full-on stress test to validate every single assumption about the new Block 3 design. The whole thing was a masterclass in methodical escalation done at breathtaking speed. It started on February 1st with a simple ambient pressure test, just pressurizing the tanks with gas to check for leaks or weak spots before introducing the brutal cold of cryogenics. With the ghost of Booster 18's failure haunting that very same test, this first step was a big one. It passed. The very next day, February 2nd, came the first taste of cryo. SpaceX did a partial cryogenic load, filling the liquid oxygen tank and the smaller methane landing tank with ultra-cold liquid nitrogen. The booster emerged lightly frosted, a beautiful and welcome sight for the engineers. The goal was to see how the structure would contract and behave in the extreme cold, where the steel gets stronger, but seals and welds are put under incredible stress. Then, the pace went into overdrive. On 3 consecutive days, February 4th, 6th, and 7th, Booster 19 was put through a trio of full cryogenic proof tests. This meant loading both massive propellant tanks at the same time, filling the whole vehicle with thousands of tons of liquid nitrogen and holding it at flight-like pressures for hours. The booster sat on the stand, caked in a thick layer of ice, venting billows of white vapor as it was subjected to the intense cold and pressure it will face on launch day. 4 cryo tests in just 6 days is basically unheard of in recent Starship history. You'd have to go back years to prototypes like Booster 10 to see anything like it, but it was absolutely necessary. With a totally new design, SpaceX couldn't trust the data from all the tests on the old Block 2 vehicles. They had to start from scratch. They needed to hammer on this new booster until they were absolutely confident it wouldn't break. This rapid-fire testing was only possible because of major upgrades at the Massey's site. In the past, testing speed was often bottlenecked by the tank farm supplying the liquid nitrogen. Recent expansions now allow for simultaneous full vehicle loading, a critical piece of this accelerated puzzle. Extra subcoolers have also been installed, letting the team chill the propellants even further and keep things stable for longer. This isn't reckless speed, it's planned, enabled acceleration. By February 9th, Booster 19 had survived its trial by ice. It passed with flying colors and was rolled back to the Mega Bay, a validated piece of hardware, ready for the next big step, getting its 33 Raptor 3 engines. The success of this brutal testing campaign was a huge sigh of relief, proving the lessons from Booster 18 were learned and the core structure of the Block 3 booster was sound. But the booster is only half the rocket. It also needs a place to launch from, and for Flight 12, that's brand new too. While Booster 19 was being frozen and stressed out, a different kind of trial was happening just down the road. At the orbital launch site, all eyes were on Pad 2. And make no mistake, Pad 2 is not a copy-paste of Pad 1. It's a next-generation launch facility, engineered from the ground up with the hard-won lessons from every single Starship launch, and designed specifically to handle the raw power of Block 3. The most critical upgrade, and the one that shows the biggest philosophical shift in pad design, is what's under the launch mount, a massive water-cooled flame trench. We all remember what happened after the first integrated flight test in April 2023. With no flame diverter or water system, the 33 engines of Booster 7 acted like a giant plasma torch, obliterating the concrete pad and blasting debris for miles. SpaceX spent months rebuilding and retrofitting Pad 1 with a steel, water-cooled flame deflector. It worked, but it was a reaction. Pad 2 is proactive. It was designed from day one with an integrated flame trench and a vastly more powerful water deluge system. This isn't just about preventing damage. It's about enabling higher performance. The trench is made to safely channel the unbelievable energy away from the pad and the rocket, which might even allow for longer static fire tests to get better engine data. In mid-February, SpaceX put this new system to the test, and the footage is just breathtaking. An enormous torrent of water, about 350,000 gallons of it, erupts from the flame diverter in a kind of controlled chaos. This system has one job: absorb the apocalyptic acoustic and thermal energy from ignition. When Booster 19 lights all 33 of its Raptor 3 engines, it will unleash around 17 million pounds of thrust. That force can shake the ground and create sound waves that shatter concrete. The deluge system has to tame that energy, suppress the sound, cool the pad, and protect the multi-billion-dollar vehicle sitting just feet above the chaos. Passing this deluge test was one of the final, most crucial infrastructure hurdles for Flight 12. It's a milestone that doesn't make headlines, but it's an absolute gatekeeper for the launch. No validated deluge system, no static fire, no launch. With this test done, Pad 2 was officially declared ready for action. The commissioning of Pad 2 is a game changer for Starbase. It's not just about having a backup, it's about tempo. A second operational pad means SpaceX can, in theory, process one vehicle for testing while another is on a pad getting ready for launch. This is the kind of rhythm they need to hit the high flight rate that is central to Starship's entire purpose. For Flight 12, it means a pristine, purpose-built arena is ready and waiting for the debut of a new generation of rocket. This deep dive into Starship's tech and testing is incredibly complex, and keeping all these details straight requires a clear mind. If you're looking to boost your own focus, I've been using a supplement from our sponsor name. It's helped me cut through the noise and stay sharp while researching these scripts. I really believe in their product, and they're offering a special discount for viewers of this channel. Click the link in the description below to learn more and support the channel. It's a great way to help us continue making these in-depth analyses. Now, back to the engines that will power Flight 12. At the heart of Starship's power are the Raptor engines, and for Flight 12, we are entering a new era. Booster 19 and Ship 39 will be propelled exclusively by Raptor 3s, a generational leap in performance, efficiency, and design. The Raptor 2 engine was already an engineering marvel, but Raptor 3 is on another level. The headline number is the thrust. A single sea-level Raptor 3 can produce up to 280 metric tons of force, a staggering 22% increase over its predecessor. Multiply that by the 33 engines on the Super Heavy booster, and you get a total liftoff thrust of over 9,000 metric tons. That's 17 million pounds we talked about. This is by far the most powerful rocket engine in production. But the upgrades are about more than just raw power. The Raptor 3 is a masterclass in simplification. SpaceX engineers have aggressively eliminated complexity, integrating plumbing and sensors directly into the engine's main structure. This streamlined part-deleting design makes the engine not only lighter, but also more reliable and easier to build. A Raptor 3 weighs about 100 kilograms less than a Raptor 2, and an incredible 500 kilograms less than the original Raptor 1. When you have 39 of these on a full stack, that weight saving is enormous, translating directly into more payload to orbit or better margins for landing. This philosophy, making the engine simpler, lighter, and more powerful all at once, is counterintuitive, but it's the secret to SpaceX's rapid innovation. However, introducing a brand new engine design across the entire vehicle is another huge variable in the risk equation for Flight 12. While these engines have been tested extensively at SpaceX's McGregor facility, they have never flown. Their performance in a real ascent, firing together with all the complex interactions of vibration, acoustics, and fluid dynamics, is still an unknown. The static fire will be the first time all 33 booster engines light up at once, but the real test is the flight itself. And this brings us to the other half of the stack, Ship 39. While Booster 19 has been acing its tests and is now in the Mega Bay getting its engines, the upper stage has been conspicuously absent. As of mid-February 2026, Ship 39 is fully stacked but just waiting. Its path to the launch pad is currently blocked. The delay comes from a bottleneck at the Massey's test site. The cryotest stand needed for a Block 3 ship is currently occupied by a structural test article, Ship Test Tank 18. That tank has to finish its own series of tests before it can be moved, clearing the way for Ship 39 to start its qualification campaign. This creates a tense parallel timeline. The booster is racing ahead, but the ship is stalled at the starting line. For a launch to happen in early March, Ship 39 needs to roll out, complete its own battery of ambient and cryo tests, and maybe a static fire of its own 6 engines, all within a compressed window of about 6 weeks. It's doable, but it leaves zero room for error. Any problem during Ship 39's testing, a leak, a bad sensor, a valve that won't open, could immediately push the entire Flight 12 schedule back by weeks. The race to launch is now a two-front effort, and the critical path is getting narrower by the day. With all the pieces rapidly coming together, the road to Flight 12 is now a clear, if treacherous, sequence of events. Each step is a gatekeeper to the next, with one milestone looming larger than all the others, the full 33-engine static fire of Booster 19. Here's the roadmap from where we stand. First, Booster 19, now with its engines and grid fins, has to roll from the Mega Bay to the newly christened Orbital Launch Pad 2. Once it's on the mount, it will be hooked up to the pad's ground systems and the quick disconnect arm, ready for its final, most violent ground test. The static fire is the dress rehearsal for launch. The booster will be fully loaded with cryopropellants and, for a few brief, earth-shaking seconds, all 33 Raptor 3 engines will ignite at once. Engineers will be watching dozens of critical signs. Did all engines ignite cleanly? Did they hit their target thrust? Are the thrust vectors aligned? Do the vehicle's computers handle the immense vibration and stress? This test is the single biggest remaining risk for the booster. Any anomaly, a sensor reading that's off, an engine that shuts down early, or worse, a hardware failure, would stop the whole campaign cold. The team would have to detank the vehicle, sift through terabytes of data to find the problem, and maybe roll the booster back for repairs, a process that could add weeks, if not months, of delay. If, however, the static fire is clean, the floodgates open. SpaceX will move with incredible speed. After a rapid data review, the final launch license applications will be filed with the FAA. While SpaceX has an FCC license for communications that opens in April 2026, the company is aggressively targeting a launch in early March. That shows just how confident they are in the hardware and their relentless drive to keep moving. The flight profile itself will be ambitious. The main goal is to validate the performance of the entire Block 3 system. For the booster, this will likely mean attempting a return to the launch site and a virtual landing just offshore, setting the stage for a catch by the launch tower arms on a future flight. For Ship 39, the goal is to reach orbital trajectory before performing a controlled re-entry and a soft water landing in the Indian Ocean. Every second of the mission will be a treasure trove of data, providing the first real-world information on how this new generation of Starship performs. But before any of that can happen, Booster 19 must first survive its trial by fire on Pad 2. The entire program is holding its breath, just waiting for the ground to shake. So that's where we are at this pivotal moment in spaceflight. A brand new, untested Block 3 booster has just survived a punishing test campaign born from the failure of its predecessor. It's about to be armed with 33 of the most powerful rocket engines ever made. A brand new launch pad, Pad 2, with its massive flame trench and deluge system, has been validated and is waiting to host its first launch. But the risks are immense and layered. The jump to Block 3 is a full generational leap, not just a small step, with dozens of new variables in play. The Raptor 3 engines, for all their power, have never flown. The other half of the rocket, Ship 39, is on a tight schedule, racing to finish its own testing. And the all-important 33-engine static fire, the final gatekeeper on the ground, still lies ahead. This is why SpaceX is risking it all on Flight 12. This flight isn't just about getting to orbit. It's the crucible where the entire next phase of their ambitions will be forged. A success validates the Block 3 design, fast-tracks the path to orbital refueling, and keeps NASA's Artemis program, which relies on Starship for its lunar lander, on schedule. A major failure could mean huge delays, a redesign, and a serious blow to the dream of making humanity a multiplanetary species. The next few weeks will be some of the most intense and consequential we have ever seen at Starbase. SpaceX has placed its bet, pushing its technology and its teams to the absolute limit. The question now is whether this massive gamble on the Block 3 generation will pay off on the very first try. What do you think is the biggest risk for Flight 12? Is it the new booster design, the unflown Raptor 3s, the tight timeline for Ship 39, or the static fire itself? Let me know your thoughts in the comments below, and if you want to stay on top of every development on the road to this historic launch, make sure you're subscribed. This is a story you won't want to miss.